you've learned a lot in this unit. There's a lot of different types of air pollution that have different problems, different sorts of chemistry. You got to keep them all straight. The College Board asks a lot about air pollution. And now that we get to indoor air pollution, I'm sure you'd think, well, it's the last study goal in the chapter is probably minimal, but it's not. Indoor air pollution turns out to be almost as deadly. Like in the United States, it's equally deadly. Globally, outdoor air pollution is still worse, but in the US, you're just as likely to die from air pollution inside your structures as you are outside. This is a big deal to the American public. It's just another of the study goals as far as the College Board is concerned, but I don't want you to diminish its importance. This tends to be a really dangerous part of modern life. And there's a few things I need you to know in addition to what the book had. Um, First of all, as always, um, poor people face this air pollution much more than the wealthy. And in this country, poor has a correlation with race. So this is a biased exposure. Um, as with other air pollution, um, people who already are less healthy are the most susceptible, um, or people who have a whole bunch of exposure are the more susceptible. So the elderly who already have compromised circulatory respiratory system, and the elderly who spend a whole bunch of their lives in the same places sometimes. You can imagine that, like other air pollution, already being sick or spending a lot of time there is bad, more bad. And your book has these like really useful two sections that break down all of the pollutants. Most of those I think are really important. There's a diagram that shows a house with all the rooms, and next to that there's a table that explains all of the pollutants. I think that's really useful. And I'll just say use the book because I don't need to read all of that to you, but there's a few that I want to point out, like HVAC systems. Now, in my previous study guide, this was an independent study goal. I didn't give it a star because it's still part of 44. But this is a separate study goal back in the day. HVAC stands for heating, ventilation, and air conditioning. In some of our homes, it's the same machine. In some of our homes, they're separate machines. In some of our homes, you just have air conditioning or you just have the heater. But it's those like central ducts that move stuff around your house. These are actually responsible for a whole bunch of problems, and most of us don't pay enough attention to our HVAC systems. They keep stuff moving because the air doesn't settle. And they might take pollution that affects one room in the house and spread that around throughout the whole house. Plus, as moisture builds up, like even from condensation on those filters, because you're moving all these spores and stuff, you tend to start farming mold and bacteria on the filters. I have seen some grotesque stuff on people's air conditioning filters. My own mother-in-law had like an emergency where her air conditioner stopped working because she didn't know she had to change the filter, and it was trying to push air for like 5 years through this green mat of like hair and gelatinous mold, and I don't know what the heck was growing in there. But when the guy brought it out, he was like wearing respirators and he's holding this tray that looked like a green jello mold, and my mother-in-law had been breathing that like for I don't know how many years. The air filters and HVAC systems can get really, really, really funky. And some of that funk is really dangerous. Maybe you know that there are mold which are toxic. Technically, if you're a bio nerd, it's rad. That's mold warfare. So they release toxins to kill other molds when they feel that they're threatened. So the mold will be trying to eat something. It'll notice the presence of a separate mold species, and then they'll start to send out these like toxins to kill each other. And when those toxins reach us, they can be really, really dangerous. The bulldog in these fights is black mold. There's a species of black mold which gives off these extremely hazardous toxins. And what's crazy is we have mold inside of us. Most of them are benign, but if black mold gets in there, the black mold will start a fight with the other molds inside of us. And so we can build up this like black mold toxicity in the system and in our bodies. Holy mackerel, that's really bad. Once black mold gets started in a house, those spores start growing anywhere that there's moisture, carbon, and darkness. So you can imagine like a house that's got a water leak in the walls, or that has a leaky roof, or that has its feet down in wet soil. You never get rid of the moisture, so you never get rid of the black mold. And once it gets inside of our bodies, it's really hard to get rid of. So this is actually one of the leading causes of indoor air pollution illness. There's also toxic bacteria that are less of a problem, generally speaking. But they can contribute to this thing called sick building syndrome. Sick building syndrome is a separate study goal in your study guide. But sick building syndrome is where all the people in a structure share symptoms of illness because they've had the same exposure to something. Okay. The most common indoor air pollutant in the United States and maybe in the world, I might be wrong about that. I think wood smoke would probably be the worst in the world. But I'm pretty sure that the most common in the US anyway is tobacco smoke. And I'm not judging anybody. Like I hate to be like a prude about how you're supposed to live or whatever. I used to smoke cigarettes briefly, and it's just such a bad call. It's like such a bad call. First of all, remember, this is a synergistic effect because it makes you more susceptible to all other air pollution. It also makes you more susceptible to things that make you sick that aren't air pollution, like the flu and the cold. And hey, it's COVID times, so smokers are much more likely to catch and suffer from severe symptoms of COVID. Remember that smoking paralyzes your filtration system. So you have ciliated tissues that move mucus up your respiratory system, and that's a very effective filter. I'm sorry if it grosses you out, but it's a really good thing. Smoking freezes that part of your system. So smokers have more pollution reaching their lungs. And that's a clear thing for you to note. Secondhand smoke, even if you're not smoking, but other people around you are, can be almost as bad. So average levels of secondhand smoke is kind of like smoking about 10 cigarettes a day. So people who live with a smoker are basically smoking a pretty solid cigarette habit. And man, if you want, just Google it. The list of toxins in cigarette smoke. I mean, everything bad you've heard about in this unit, plus a bunch of stuff you've never heard about. Carcinogenic stuff, oxidant stuff, acid stuff, toxic stuff, particulate stuff, teratogenic stuff, like things that affect your development. Heavy metals, hey, nicotine itself is toxic. It's all in tobacco smoke. So that's kind of an gnarly one. So there's a few interesting details, like insulation laminates. Like laminate is something with a lot of layers because there's like glues in there. So laminates, carpeting, cheap masonry, cheap paint, contain all sorts of toxins. And so when you're doing your stuff out of the book, you'll notice that a whole bunch of these are building materials. Like we literally build our homes out of stuff that's hazardous. And it's probably worth noting somewhere in your notes that these are worse when the structure is young. Like if you move into an emergency shelter trailer that was just built a couple days before, like after a hurricane, a lot of people need emergency shelter. So we order a whole bunch of trailers from companies that can truck them out to like a evacuee camp. A lot of those, because they're just assembled, the material is still curing. So you know how like fingernail polish takes a while to get hard and then you got to wait a while for it to get really hard, or like paint will stop being wet but it'll still be sticky for a while. That off-gassing has a whole bunch of volatile organics, reactive hydrocarbons. I'm looking at my fishing rod I just finished and the epoxy's done, but you know, it still has a while before it's fully done. The young materials, the curing materials can be really dangerous and they really build up in a house. So when you like hurry to occupy a structure, you're much more exposed. Like if you repaint and you open the windows and you give it a month, by the time you move in, you don't really smell the paint anymore. But if you repaint and then you're like living in that house as the paint is drying, that's really hazardous to you. Or like if you buy brand new carpet and you take it out of the roll and you put it down and you start walking on it that day, that's a whole lot worse than buying carpet, installing it, waiting a month, and then moving in. People who work around large electronics are exposed to tremendous levels of oxidants, ozone and others. Something about electromagnetic fields, I'm sorry I can't really explain this better. It's true of all electronics. So all of us receive small background exposures from like television and coffee machines and whatever. But really big electronics generate huge amounts. So people who work at like server farms that host multiple websites, my buddy Ovi used to maintain a server farm in Santa Barbara right next to the high school. Um, and he had to use like really fancy respirators. They had like ozone management scrubbers in the air that would like move stuff around and like mix the air with water to make this like hazardous fluid that had to be disposed of. And they had like huge fans that would blow all that stuff out of the room where he was working. And still he said that he would like have exceptionally high ozone exposures as a worker, got hazard pay, had to get tested regularly to make sure he wasn't being exposed too much. So anyway, some people who work around big electronics get a lot of oxidant exposure. And something that we often forget is cleaning supplies. Like that's pretty gnarly. Every now and then you'll hear about some poor kid who doesn't know better mixing 2 bottles of stuff to clean a sink or whatever. So cleaning supplies can be bad. And there's one last thing I want to tell you about in this assignment. It's called the chimney or stack effect. It's just a bad way to design a building. So this is really common with buildings of a certain age, like early high rises or early like towers. You can do this in all sorts of construction. South Coast Plaza, a big indoor shopping mall in Orange County, where I wasted some of my time because I lived there for a couple of years of high school, actually has a pretty well documented chimney effect. And this happens all the time. But nowadays we usually prevent it. So modern structures usually don't let this happen. The idea is that if you have a big building that's catching sunlight at the top, or where all the occupants are running heaters, then all that hot air is going to move through the building and continue to rise until some guy upstairs opens a vent, walks out on the roof, opens a window, and that lets all the hot air leave. And if the building is drafty, then exiting hot air at the top will draw cold air in at the bottom. That's just called convection, where the air is moved by differences in temperature. So the hot air leaves and the cold air comes in. You've probably experienced that part somewhere else in your life. If you go up to the attic of your house, when the light is just right, you can see all the suspended dust in the air going out of the vents. And then if you put your hands on those little vents at the side of your attic, you can feel cold air coming in from outside. It's not rocket surgery. Convection is simple. You could probably just say on the AP test, it's poorly managed convection currents, or drafty or open convection currents. But now I want you to imagine what it's like if you're in Manhattan in some old tower with a bazillion people going in and out of the front door in spring when it's really hot in the sun, but the streets of Manhattan are all shaded and cold and there's ice on the ground. When it's cold like that, all those cars, bumper to bumper traffic in the streets of Manhattan, are just idling, just putting out car exhaust. And as people go in and out of the house, they're allowing cold air from the street to get sucked in to the building, right? Because somewhere in the building, hot air is leaving, cold air from the street is being sucked in at the street level. So you literally fill a tower with car exhaust. It's like really, really, really severe. People in their building, because of the circulation system, end up living in car exhaust, breathing that all night. You wake up and you make your kid breakfast and everybody's just inhaling fumes from the cars outside. It's a pretty humongous oversight in early building design. Now we make buildings to be smarter. We force air out at the bottom. We contain the layers of air between floors of a tall building. We use fans to push out air that would be trying to climb up the building. But back in the day, this was not something we knew about. So a whole bunch of older, tall buildings are unfortunately designed to suck in air pollution. Okay, don't forget, I really mean it. There's 2 sections of your book where you have a lot of stuff to note. Okay.